Welcome back. In this final part, we now want to talk about the ethical challenges that surround artificial intelligence. So, in more detailed terms, we are asking how can we ensure accountability, responsibility, and liability for artificial intelligence? And these terms, of course, have particular meanings. Responsibility means accepting potential costs, duties, and obligations of one's decision, that someone is being held responsible for an action and its outcomes. Accountability means that it's defined who's being answerable to others for decision made and action taken. Now, very often, responsibility and accountability are um, roles assumed by the same actor, but it doesn't have to be, right? So, for example, parents are responsible for actions of their children, but children are accountable, yeah, or are being held accountable. Liability means that there is a process that ensures that responsibility and accountability can be accepted so that individuals can recover damages done through them to breaches of responsibility. Yeah, so that means these three things are defined, and these could be three particular challenges that could be applied to artificial intelligence. So, what we want to do here is give you a little bit of a background into what we mean with ethical challenges. Ethics, as many of you will know, is a branch of philosophy that addresses questions about morality, and in that meaning concepts such as good and bad, right and wrong, justice, injustice, fairness, unfairness, virtue, and evil. Or more broadly speaking, ethics are defined as a set of moral obligations that define what we mean with right and wrong conduct in a particular community or profession, so that we can use these terms to guide individuals in their choices and behaviors to make sure that they are doing the right things or the good things and not the bad things or the wrong things. And of course, ethics are an important corner part of many professions and communities. In fact, many communities have formalized ethical codes to guide how people should behave in that community. The most famous of these is probably the Hippocratic Oath taken by medical doctors, which, amongst other things, states that doctors should do no harm to their patients. You know, similarly, we have in engineering disciplines we have a professional code of ethics, the Professional Engineer Code of Ethics, which, amongst other, states that engineers must hold paramount the safety, health, and welfare of the public. For example, when constructing bridges, buildings, roads, stuff like this. And in fact, this also spans into the technical disciplines. For example, there is a very famous first law of robotics that states an ethical principle, namely, a robot may not injure a human being. And this is supposed to be a principle that is ingrained in any action that I program into a robot. Now, one could very simply say, well, that's wonderful. We're just going to have a similar ethical code for the AI community. Well, the big challenge or the big problem is that we do not have such a comparable ethical codes that exist in the context of AI. Now, this is not to say that there are no ethical code around surrounding AI, but they're not on this broad community professional level, accepted level like these ones are, right? So it's not just that some doctors do the Hippocratic Oath. No, all doctors do this. In the Western world, there is this professional engineer code of ethics that holds for all engineers, not just for some engineers or some engineers in certain countries and so forth. And we do not have a simple, comparable ethical codes that spans the field of AI. Yeah. So while ethical principles in most other professions are ingrained in everyday practice, yeah, so they're part of the way that a profession is practiced, whether it be the medical doctors, the engineers building bridges, but also chartered accounting, auditing firms, or lawyers representing clients in courts, they all have ethical codes. Professors have ethical codes, researchers have ethical codes, teachers do as well, and so forth. We do not have a similar situation with AI ethics, right? And that is a problem because just like any other community of the many of these here mentioned professional communities, we can sometimes have societally pivotal or critical decisions that involve AI. Yeah, and it's not just that we have a code in these other communities. With this code comes training and scrutiny. For example, there are certification that is one that exists, and for these you need to test. You need to demonstrate your capability to understanding and applying these code of ethics. In other words, there's training, certification, examination processes, and there are also certain laws around it. What happens if you do not follow these codes? Yeah. So there could be on two layers. There are definitely, in most cases, punishable within the profession, and sometimes even by law. Right. So for example, there are a code of ethics around research, that you should not fabricate data, that you should be honest and open, and all these sorts of things. And if you do not do them, you will lose your standing. I mean, you will be punished within the profession of researchers, for example. And there are others that are so important because the behavior that is involved is so important that they're punishable by law. For example, if you're a doctor that's a fraud or that doesn't live by the Hippocratic Oath, you can literally go to jail for breaching the code of ethics. Yeah. And the challenge in AI exists because AI algorithms increasingly, now that we've seen these advances, they're actually used in contexts where they support or make decisions with very material consequences. We use AI to determine who gets hired, who gets fired, who gets a loan, who gets credit from a bank, or even how long people spend in prison. Yeah, so we do use AI in situations where the outcomes determine very material, yeah, very tangible, societally important consequences. Whether you can build a house, whether you get the job, whether you lose the job, or even if you go to prison, right? So algorithms do create moral consequences. They can even reinforce or undercut ethical principles, and they can enable or diminish stakeholder rights and dignity. So by all means and purposes, um, AI is involved in behavior that is societally relevant. The problem is that we don't have training, nor scrutiny, nor a generally accepted code of ethics for those that are involved in building and using the AI, such as designers and developers that construct these AI algorithms. Yeah. And again, this is not to say that no code of ethics exists. Here's an example. This is the ethical code of Google AI. Yeah, so you can go to AI Google/principles, and you will see a code of ethics that is purportedly or reportedly the code of ethics that governs the AI engineers at Google's. Yeah, so, for example, you see here, be socially beneficial is a guiding principle. So while that is obviously a good thing, there are two issues here. Number one, this is Google's principles. They may or may not be Microsoft principles. They may or may not be an open source AI developers principles. So they are not universally accepted. This is a company owned thing. Secondly, we don't know and we can't scrutinize to what extent A, they're being lived, or B, they're being punished, to sort of what extent we have training, certification, examination, or due diligence, so sort of liability processes that actually come with these principles. So if I had to say this very harshly, it's a fine looking web page, and whether or not that has any consequences, we don't actually know. Yeah, and we can't actually evaluate or scrutinize, and even if we did, it would have very little effect, because even if we found out that no one actually follows these principles at Google wouldn't care. Yeah, because we have no authority over what Google does. Yeah, so by the way, this is not about Google, of course. This is just a very famous example, and it's actually one of the few cases that actually declared open ethical principles. So I'm not just saying here this is a bad thing. I'm just saying this is not good enough. So I'll give you an example for when I say AI can have very material consequences, and it can both enable and diminish stakeholder rights, and can do, it can actually have good and bad consequences. This is a very famous case, namely when Amazon started using an artificial intelligence tool to support the hiring decision. Yeah. So that means they had an AI recruiting tool, which effectively works that job candidates upload a bunch of materials like their CV, very often also a little image, a video of themselves, like when they do an interview, or maybe their textual responses to an interview. So all sorts of material. And what the AI does, effectively, it tries to extract from the data given by candidates certain personality profile data. Is this an extrovert? Is this an introvert? Is it likely to be charismatic? Does it show signs of leadership? These sorts of things. And then the AI actually matches the profile of the candidate based on the data provided with the profile of employees that Amazon has and that they find desirable. So, in order to train this artificial intelligence, what Amazon did, or how this works, is that it is basically giving the AI some training data based on profiles of jobs, profiles of employees that they find desirable. Good leader, charismatic, introvert, or maybe a little bit extrovert, or whatever. Yeah, and they use that as input for the AI, so that can then compare all the job candidate profiles to this desired profile. Um, and this is went very public for a simple reason that at that point, most tech companies, including Amazon, basically had a large majority of male employees. Yeah, so techie companies didn't hire a lot of women. A lot of women um, didn't want to. Maybe didn't want to. In any case, there was definitely a bias towards male companies. By the way, it's the same at university. If you look at how many male versus female professors does the university have, including University of Hamburg, it's about 70-30. And it's actually one of the best in Germany with a ratio of 70-30. So it's a far way off from 50-50. So similar situation here. Now, what happened with this hiring algorithm is that it started doing this, and it actually suggested Amazon to hire basically only white male dudes. Yeah. Why? Well, because they were closest to the profile of those employees or Amazon already had and found desirable. Yeah, most of the people were male and white. Most of the leaders were particularly male and white. And of course, if you look for, all right, I want to get close to that particular profile, that's exactly what the AI is going to get you, right? So in this sense, the AI recruiting tool was actually sexist. Yeah. Um, so this is just one example. It went very public. There's a few more of these in similar situations. There is, for example, also studies of AI in advertisement, and what sort of like sort of model profiles an AI would suggest, and it's all basically Caucasian, European, white females and males. No diversity in gender, in shades, in ethnicities and races and so forth. So it can be actually quite an unethical thing that the AI does. Here's a model that explains to you why that is so difficult. Yeah. So in AI, for example, in machine learning algorithms, you have a lot of consideration points where you have to weigh in ethical decisions, right? So in the algorithms, you need to figure out what rules and policies to apply within the algorithms and how to encode an ethical norm into an algorithm. But it's not just that. It also concerns the training data that you use to train what the AI should be doing. Yeah. So what about this data? Maybe this data is biased, as in the example of Amazon. It fed the algorithm a set of data that was actually gender biased because it was mainly males. So the AI learned to hire mainly males. Yeah. So there could be just and unjust biases and implicit and explicit biases in the training data that you use for the algorithm. Then, of course, a second set is what sort of data do you actually get in the actual decision-making support by the algorithm? What about that data? Is that fair data? Is that biased in any way? Is that accurate data? Yeah, so there's another piece of thing, a concern that requires ethical deliberation. And finally, any outcome that is produced and maybe even actuated. How about that? Is that an ethical decision? Is that an effective? Is that biased? Is that fair or just in any way? So you see here, it's quite a lot to deal with, not just the algorithm that needs to be. And to illustrate how that works, I'm talking you through one example of the difficulty of building a fair algorithm. Yeah, so to make sure that an algorithm doesn't unjustly have a bias towards or against certain types of candidates. Yeah. So what we mean here, fairness means that treating others as one wishes to be treated. Yeah. Following agreed upon societal standards. So at the moment, for example, we expect fair hiring to not have a bias for or against women. We also, by the way, have a law that says we shouldn't be biased. We should treat people with a handicap disabled applicants or people with certain medical conditions, just as we would treat others. That's the fair thing to do, right? So this is what we mean with fairness. Then one of the issues in building a fair algorithm is that there's such a thing called protected attributes. Yeah. So by law, it is not allowed to make any sort of decisions, such as choices or selections, um, because they could be used for discrimination. So you're not, by law, by constitutional laws, you can't discriminate based on religion, gender, origin, marital status, age, socioeconomic status. It's not allowed, right? You can't. I'm gonna be very outspoken here. You can't not hire a person because they're black, because they're Jews, because they're female, because they're too old or too young, anything like this. This is all discrimination. So these attributes are protected. What does it mean? It means you can't use them to make your decision. And even your algorithm cannot use them to make a decision. Now, and this gets very complicated. Again, this case is from the Netherlands, because the Netherlands, a couple of years ago, in 2019, they decided to start using AI in their police work for what's called predictive policing. Now, the idea here is that you use an algorithm to determine in advance whether it's likely that a crime will occur in a particular neighborhood in the future, so that you can send a police group there to basically prevent it from happening. For those of you old enough to remember, it's kind of like the Minority Report, the movie with Tom Cruise, just real put it into action. How did it work? They had an algorithm that basically took a city map. They used the cities of Amsterdam and Rotterdam, yeah, and they divided the map into 125 square meter squares, yeah, little lots, square lots, and for every square, they then decided to grab crime data. Yeah, and it's specifically a technical variable that they needed, for example, like latitude and longitude and stuff like this, and 47 variables they used for prediction. These were 19 population-related variables that they got from the Netherlands Census Bureau, the Office of Statistics, such as what's the house price, the average age, how many social benefit recipients do we have, how many immigrants live in this area, how many one-person households do we have, and 28 crime-specific variables that they got from their own crime database, their police information systems. Number of reported burglaries, time since last crime, and so forth. Yeah. And then the algorithm, what it did, it actually took these 47 variables and transformed this in a logistic regression. A logistic regression basically regresses a set of variables into a 0 or 1, yes or no, black or white. Yeah. And it determines the probability that a crime will occur, yes, or a crime will not occur, no. And these probabilities, 20%, 40%, 60, 80%, and so forth, you can then depict graphically, and you see a screenshot on the right. So you can see the entire neighborhood in blocks of green, yellow, and red blocks. We'd say the red block, it's quite likely that there will be a burglary, say, this weekend. So this is what this algorithm did. But as you can hopefully see here, it actually is discriminatory, right? So it actually makes these decisions based on population level data that is by law actually protected. Yeah, because it actually discriminates against immigrants. It discriminates against socioeconomic status because it looks for such a thing such as how many social benefits recipients live in this area. The reasoning, of course, is that it is, in fact, more likely that if you have immigrants and low income, you will have more crimes. There's a strong correlation, not a causation, but a strong correlation. But still, it's actually by law not allowed. By the way, the Netherlands, this pilot project, they stopped that at some stage. There was a big backlash here. So this is difficult, right? And you can see that some of the solutions out there don't do the right thing. They're not fair, they're not ethical, so to speak, right? And if you're interested in this topic, there's a really interesting paper here by Lily Morris and Mike Teodorescu and others. And they looked at algorithmic fairness and had a look at various ways in which you can try that. It's actually really difficult. Yeah, I'll show you 3 examples. So one of them is called fairness to unawareness. The idea is very simple. You're not supposed to discriminate, and there's a range of protected attributes such as religion, status, gender, income, immigration status, and so forth. Well, let's just leave them out. Simple, right? Then I'm doing the right thing, I'm doing the legal thing, and so forth. So I'm ignoring this information. The problem is that the information that is contained in these protected attributes really strongly correlate with other information that is not protected. Now, for example, you can use data such as highest university degree, bachelor, master, PhD, whatever. Now, that's not a protected attribute. So that one you can use. But of course, this correlates really highly with other protected attributes such as socioeconomic status and migration status. Yeah, simply because over time, historically, there's a correlation between, university degree people usually come from families that are upper middle class, very often have a university degree themselves and so forth. And conversely, immigrants with low income and so forth in small households very often do not produce a lot of people that have PhD degrees. Not because they can't, just because historically they have been disadvantaged. So fairness through unawareness doesn't actually work. Yeah, and the reason is that historically our decisions that we have made in the past as society, they have been biased, they have been unfair. Yeah, and so if we just simply use this data and maybe leave out some data that we're not meant to be using, we will still perpetuate unfairness because it shows in all the decisions anyone has ever made. Yeah, so we can't actually get good data to train an algorithm in an ethical way because every data that we have from our planet is full of bias, implicit and explicit. Now, there's a very famous example here that I'm just going to mention in passing, that of Apple Credit. You could get a personal loan at Apple based on the information Apple had on you. That did leave out the protected attributes. Of course, they didn't even have that. But of course, just the buying history was already strongly correlated with protected attributes. So the Apple Credit rating system was, in fact, unfair. There's an approach to fairness that tries to counter this, and one of the classical one is demographic parity. And you would have seen this not necessarily in AI, but in many other situations. Yeah, so that means there's an algorithm that reaches a positive, a desired outcome, the same right, irrespective of the categories. Yeah, so the idea here is to make sure that you get equal group focused parity. So that in other words, you have both male and female candidates of an equal number applying for a job, for example. Yeah. So in other words, let's say you want to hire a professor, and you have one position, you have 10 applicants, and you're inviting for a job interview the same number of men and women. Yeah. So that's called group focused parity. If you have multiple groups, one of them could be disadvantaged or discriminated against. You make sure that they're of equal size. That's called group parity. The problem here is that it can actually engender negative attitudes. So this is the classic situation where someone said, "You only got this job because you're a woman," or "You only got this job because you're white or you're not white," or whatever else. And of course, it also discriminates against people that would be qualified but happen to be in a group with that's the majority. So a good example would actually be me, right? So I'm a white male European middle-aged man. So I'm actually a lot of things are biased in my favor. Group focus parity is not, because I will always be in a group that is the majority. So from my group, there will be less people invited to such a thing. So that might be more fair, but it's certainly not fair in an absolute sense. And the third approach then is what's called equality of opportunity and equalized odds, which means that you're not trying to get the same size groups, but you want to make sure algorithmically that members from each of the different groups would all have the same probability opportunity. So they all have the same odds of being hired. So that would allow you, for example, to have 10 male candidates and 2 female candidates, but you would have to make sure that the 2 female candidates and the 10 male candidates each have the same odds of being selected. Yeah. So we must ensure algorithmically that we have the true positive and false positive rate should be equal across all the categories. This gets also very tricky, especially if we don't have a single situation such as man versus female, old versus young, rich versus poor, or anything like this. But if you have actually multiple dimensions, let's say you have race, ethnicity, religious, sexual orientation, gender identity, and other attributes. if you wanted to have either group focused parity, you would actually need a lot of applicants. So you have equal numbers in each of the different groups. So someone with a particular gender identity, a particular biological gender, a particular religious orientation, particular ethnicity, particular socioeconomic status, and that across all the different combinations of attributes. And here, similarly, if you're trying to up the odds for one particular minority, you're changing the odds for everybody else. So it's really difficult to actually get in a fair pool from which you make your decision. And sometimes, very simply, you do not have enough data. You do not have enough data about particular cells of a particular combination of, let's say, religion, gender identity, sexual identity, socioeconomic status, age, and so forth. So it could well be that for some of them, there are literally zero candidates in the pool. So what does it mean? What it really means is that algorithmic fairness is, first of all, is computationally impossible. Secondly, the answer is, as very often, it really depends on what you need and what you need it for, right? So fairness through unawares is rarely suitable to anything. The other one is that you have some approaches that are somewhat fair and they could be used for certain situations or context. But what I've actually blended out here a little bit is they're also they have different challenges in implementing them and actually being able to produce such an algorithm. So sometimes the ability can be only low or high, or the effort is really high. So really, it depends on where you want to use this. So this was just meant to give you an example of trying to do something like, let's build an ethical AI. It can actually be really, really, really tricky. Yeah. And so what is the solution about ethical challenges in AI? Well, we don't really know. Yeah. What we do know is that we have a few different approaches floating around, and I'm just summarizing them here. For example, we now have something that you could call ethics-oriented design principles. So we do have a whole range of normative standards for what's good AI development. I showed you the Google principle, for example. Here, one of the challenges is that we don't have a universally accepted one. We also don't know which of them is good, bad, more or less implementable, and so forth. A second idea that's floating around at the moment is this idea of a human in the loop. The idea here is that whatever AI is doing, and even if it's unsupervised and truly autonomous and so forth, you need to maintain human supervision and control at all times. The human must always stay in the loop somehow. Here, the question is to determine the exact configuration for a particular task, a particular objective, for a particular AI, when and how, what that human in the loop actually means. Yeah. The third aspect that people are working on at the moment are, just like in the other professional communities, to develop education and certification teams. So work on training for ethical AI. And of course, there's an entire legal procedure happening that we're trying, especially in the European Union, that people are trying to come up with standard norms and laws to safeguard responsibilities. So AI regulation is a hot topic. So these are four big challenges or four big developments that are going on around surrounding the ethical challenges of AI. And what we're doing here is we're trying to figure out which of them works, what can we do about them, and to do some research around some of these approaches and others. So, as the final piece of work that I want you to do, I want you to experience that yourself. There is, when you go to this webpage, there's a really interesting interactive article, yeah, in the MIT Technology Review, which is basically a courtroom algorithm game. So when you read this, you actually have to make legal decisions. So basically, you have to decide whether or not certain people should be jailed or not jailed. Yeah. And it teaches you about how such an algorithm actually tries to make a fair decision. And it will also teach you how difficult it is to make a fair decision yourself. And that concludes our introduction to AI and the ethical challenges that surround this. I hope you enjoyed it, and I wish you good luck for going forward. And I'm looking forward to sharing the rest of the seminar with you.